We're down to the data encapsulation. Now, how do I segment? I've got this War and Peace that I want to send you. I want to make sure you get the whole book. So the question is, I need to encapsulate. I need to change. I need to break this up. I need to segment that book into a way that can be easily handled for our internet. Have you ever had a 25 meg file that you wanted to send to somebody? Guess what? You didn't tie up all the network just to send that one file. Now, you may have gotten rejected because your application says it's too big to send, but when you send something that has to do, I've basically got to break it into smaller pieces, and that just basically helps me increase the speed, and it just increases efficiency, making sure that if any one segment of my network fails, I have a way of maybe with the routing protocols to get around that so that my package can still be delivered. It may be a little bit slower, and the protocol handling, the TCP protocol can then say, oh, I got to put this stuff back together. Package 2 came before package 1. I got to put them in the right sequence. So that's kind of what we're trying to do here. We're trying to break up this message, and what we're trying to do is to ease up the speed. We've got to do a couple of things. We got to break up messages, and here if I want to segment the message, I got to break it into small pieces. I got to have a bigger message, put it in smaller pieces, and send it. But now, question is, I got two people on this network. What do I do? Well, what we do is something called multiplexing, where basically says I'm going to take my package, and each person's package gets shared on the same network. So I may have two large files, two different people trying to send them, but I'm going to take bits and pieces of each one, and I'm going to send them separately. So send one versus the other, and there's different algorithms and stuff out there which the protocols go through, but we're not going to worry about it. But just know that when I have multiple people in the network, they're going to multiplex their messages. They're going to segment them, and then they're going to interleave them onto the network so that everybody gets some aspect or access to the network. Now, of course, since I'm doing multiple segment, breaking this down, segmenting my message, I've got to make sure I put them in the right sequence. So you're going to assign a sequence number to each segment, and that your TCP will keep track of who has it, because TCP, being a control freak and want to make sure each package gets together, it's going to make sure, do I have all the packages? I'm expecting 40 of them. Wait a minute, I've got 39, or I've only got, which order did they come in? Because they are not coming on, in this picture, it's very easy that, they'll come in 1, 2, 3, 1, 2, 3. Well, if I'm sending it across country, I may go through 1,000 different routers and switches and devices and different technology. So I may get package, number 2 before number 1, and it's up to TCP to say, hey, I'm going to put this back together, resequence them when it gets all to the end to say, I've got all my packages and I can go through. Now, as we go through these different layers of encapsulation, you're going to hear the term, you got a protocol stack and says, how's my information getting created and how's it going to get sent? But one, you're going to get something is called a protocol data unit. A protocol data unit is for one particular protocol, what is its unit? What is it operating on? So you've got an email, so you create a bunch of data. And once I segment it, it's okay, here's segment 1. Now I'm going to put my transport header on it. Then I'm going to go down to the next layer. I'm going to go down to the network layer to address it. So when I'm at the transport layer, my PDU is called a segment. So you got the data, transport layer, it's a segment. At the network layer, at the IP address layer, it's called a packet. Our frame, most of us talk about packets getting data from point A to point B, but basically that is the PDU, the protocol data unit of the network layer, is that. And then when it says that now I got to get down to the physical media, how am I going to interpret that? It's called a frame. Now, as you look at it, I've got all it kept doing was encapsulating information on it. So I started with data. I put in the transport header. I went down to get an address. I put the network address, both source and destination addresses on. And then as it went down to the frame, now I'm saying I got my frame header, I got trailer. Now this trailer is used for, did the message arrive correctly? And some part of this, once you finish this frame, I got to get down the physical layer, and I've got to send ones and zeros because our machines only handle ones and zeros. So just remember, you got the different layers, and then each layer has its own data unit. So you got to remember what the protocol data unit is for each of the different layers. So your physical layer PDU is bits. Your data link protocol layer is the frame. The network layer is packet. The transport layer is segment. And then your data is your application layer PDU. So just keep that in mind as you go through that. This example runs you through. I'd watched this video showing you how all these protocol data units are added to your data as it goes through from point A to point B. It's a very good example. And then knowing that on the back end, so I'm encapsulating on the transmit side, and I am de-encapsulating on the receive side. So just keep in mind. So encapsulation is I'm putting information on my data. De-encapsulation is I'm taking, I got to my frame link, because I'm receiving bits, and then what it's got to do is I've got to go through and say, hey, I got to look at my Ethernet frame. Then I got to look at my IP address. I got to look at the address, so on and so forth. And in some aspects, you may decide to, oh, this isn't for me. I'll re-encapsulate it so I don't have to process all the way down the data side, but I can get to the point and say, okay, it came from an Ethernet, but now it's going to go over a fiber cable. So I will put a new Ethernet frame on it and send it back on. Once I've checked that I am not the destination. So it'll strip this off, says, yep, I've got everything I needed. It came to me correctly. I'll check my address. Oops, it's not for me. I'll send it on to my next device. So I'll put a new address on. What's my new destination address? I'll re-encapsulate it and create new bits because it's going to be a different format because it'll be over fiber versus wire. So it won't be electrical site impulses, it'll be light impulses. So just a little bit of how that works. Now, let me see. Do I want to go? Yeah, let me go to data access too. And this will be the last things we go through. Now we're going to look at data access, and basically now you've understood that we're creating segments. But now you got to look at, okay, how are the addresses? There are different types of addresses that are being used in this. You've got, when you look at the different layers, your physical thing layer basically just has a little bit of timing and synchronization bits added to the start of your package. Your data link, the address it has is, I'm looking for a physical address. It's a physical address of the next device. And that address is what they call a MAC address. It's an address of the network interface card of the next device. Of course, the network address is the logical address. So here's, go back to letter interface. I've got a physical address, so here's my house number, the physical address on the data link side, and then I've got the logical address is my name, because the address could go to my wife. So, and then transport says, hey, I've got to keep up, since I'm having multiple conversations going on, I'm going to put a port number on so I can talk to simultaneous users. I mean, most of you in class probably have 4 or 5 apps running at one time. Well, I've only got one Ethernet or one wireless connection, one physical address, but I got multiple applications going on. Well, that multiple application is done because each of those applications are on a separate port. So I've got transport that's telling you a port. You've got a network that's giving you an IP address. You've got the data link, which is giving you a MAC address. And then you've got timing and synchronization bits at the physical layer. And here's this example of logical addresses. You got a packet, and you got a source and a destination IP. Now remember, I need source and destination, MAC addresses, source and destination, IP addresses. So as you go through these different layers, you're going to see that. Know that there is an IP address basically has two parts. It has a network portion and a host portion. Now in IPv4, this is, when I look at that number, I see 192.168.1.110. I can't tell looking at that number which part is the network and which part of it is a host, an end device. Way this is determined is there's another thing, there's a subnet mask. There's again, a 24-bit sequence that says, hey, how do I interpret each one of those numbers? And if a subnet mask is a 1, it's network. If it's a 0, it's a host. So we'll get into that a little bit later, but just letting you know that subnet mask is what determines what's host and destination. In IPv6, it's a prefix length, but it's basically the same concept. 1, it's a network. 0, it's a host. Now, if you're on the same network, this is where you don't have to go out and determine the IP address. I'm on the same network. I'm only going to look at the MAC addresses. And you remember you've got your network IP, so you got source and destination address or logical address, and then I got my source and destination physical address. These physical addresses on an Ethernet frame header are a MAC address. And as you can kind of see, their MAC address is made up of 6 octet pairs in hex. Here you've got dotted decimal notation. And if you look at this breakup here, you got network and host. So this tells me I had a subnet mask of 255, 255, 255, and 0. So just to let you, and we'll get a lot of that a little bit later, but just precursor. Now, data link, if it's the same network, I don't have to go through, data link frame is sent directly to the receiving device. So if I've got a device that's on the same network, all I'm going to do is check the MAC address and then route it through it. And the switch will do that routing for you. It'll say, hey, I'm on the same network. I don't have to go out to all the routers if I'm just trying to get to this FTP server. Now, if I was going out to this server, then yes, I would then say that MAC address got me to this. Oops, the address that I'm going to is not on the same network. It's on a different network. So now I've got to encapsulate the data link frame to the next device so that I can pass it on to this whole sequence. So you got your source MAC address, which is the data link address, the MAC address of the sending device, and the destination MAC is the receiving device on the same network. It's the address of the receiving device. Now, granted, if it's on a remote device, guess what? You're gonna ignore that. Not ignore, you're going to process the data link. Oops, I can't. It's out in the same network. I've got to pass it on to the next device who can make a determination who's going to route it onto a next device. Now, what happens with the network addresses? So what are those? Those are your IP addresses. So now this is on a packet on a different network. So it isn't the same network. If it's on the same network, I can use my MAC address and do that. If it's on a different network, I need to take it to the next level. I need to take it to the logical address, the IP address, to send it on. So now I'm looking at the source and destination of the IP address to make that determination. So my MAC address changed it to get to this router. This router then looks at the source and destination IP address and says, okay, where am I headed? Where am I going? Which route am I sending it to? What is its MAC address? And send it on its merry way. And each device it goes through is going to look at, am I the destination IP address? Sooner or later, that IP address, because you saw it was 192 network, 192.1, and this was the 172.16.10. At some point, that router is going to say, hey, that's me. It's my network. So that device I'm trying to get to, that device 99 is on my network. Change the MAC address, route it down, and then send it on its way. So each device is looking at the MAC address, making sure it's understandable, double checks the IP address, the network layer address, to see if it's at the correct destination. If it's not, move on. So just thought I'd pass it on. Now, if it's on a different network, you're going to look at MAC addresses, you're going to look at network addresses, because you're still going to have to worry about the network interface, because at some point, this MAC address, this IP address has got to associate to a physical port on their destination side. Now, let's see, do I want to show you this? This gives you a nice destination as you're going through, routing through the header, through the routers. It goes through and says, hey, which different layers? It's always going to check layer 2, layer 3, layer 2, layer 3. I'm checking network, I'm setting my MAC address, and I'm checking to determine, am I sending it on? So each interface, I'm looking here, received it, it's making a decision, am I part of this? Yes or no. If it's not, I'm going to put on the next address, pass it on. This one's going to do that same thing. I'm going to look at the MAC address information. It says, okay, I've reached my network interface. So you've reached the next device. Now let me check the logical address. Is that address something I have control over? If it is, I'll change which network interface, which interface on my router is this device on, and pass it on. And we're not going to do Wireshark. We're not going to do any of that. I'm not going to check your knowledge on that. I want you to do that. And hopefully this helped. And actually, I think that was the last lecture of this chapter. So hopefully these little videos helped a little bit. But I do want you to go through this material online and run through the tests, run through the quizzes, run through the videos, the simulators. I think it'll help you understand this material. If you have any questions, let me know. Thank you.